food additive with hundreds of varieties like fruit, vegetable, and wine, which is natural flavoring agent. Chemical flavoring agents are synthetically imitate natural flavor. Flavoring agents are used as additive to enhance, modify the taste and the aroma in natural food products, which could have got lost due to food processing. Flavoring agents also used to add great taste in food like candies or snack that does not have their own flavor.
Classification. There are three principal types of flavorings used in foods under definitions agreed in the EU and Australia. Substances which are extracted from vegetable and animal materials and are not further chemically modified or changed. An example is vanilla extract. Second, nature-identical flavoring substance. Substances that are chemically identical to natural substance but which are obtained by chemical process or by chemical modification or other natural substance. An example is vanillin, which is identical to the vanillin in vanilla but not obtained from vanilla pods. Third, artificial flavoring substance. Substance obtained by chemical synthesis or chemical modification of natural substance but which are not present in natural products. Three more flavor categories. First, flavoring preparation is a product from natural origin but which is not highly purified. For example, concentrated apple juice can be defined as a flavoring preparation. Next, processed flavorings are substances that are formed from natural substance upon processing, mainly heating. A common example is caramel, which is produced by heating sugars. Lastly, a smoke flavoring means a smoke extract used in traditional foodstuffs smoking process. These are obtained by collecting the smoke into a fluid, which can be applied in a different production process. Due to the high cost or unavailability of natural flavor extract, most commercial flavorings are nature identical, which means that they are the chemical equivalent of natural flavors but chemically synthesized rather than being extracted from the resource materials. Artificial flavors may be safer to consume than natural flavors due to the standards of purity and mixture consistency that are enforced either by the company or by law. The natural flavor extract contain traces of hydrogen cyanide, a deadly poison evolved by plants to protect their seeds from insects. This information, we get it from National Agricultural Biotechnology Council Report 2001. These are the list of non-nature identical flavoring agents.
There is two flavoring substances, which is natural and artificial. In natural flavoring substance, the flavoring substances are naturally present in plant and animal sources material. The specific substance must be separated from the natural mixture via extraction or distillation. In artificial flavoring agent, artificial flavoring substance chemically produced did not have the same chemical formula as their natural model. Natural flavoring substance is extraction. Extraction is a simple process of obtaining flavoring substance from the origin. For example, flavoring a substance in coffee preparation, we can separate the flavoring substance from the powder itself by pouring it with hot water, then filter the coffee powder. Technique, which is counter-current extraction and solvent extraction. In counter-current extraction, the counter-current extraction can be defined as a type of liquid-liquid extraction in which two components of distinct solubility in the phase of two immiscible liquids are separated. In this method, two immiscible liquids flow in opposite direction. Solvent extraction is a method to separate compound or metal complexes based on their relative solubilities in two different immiscible liquids, usually water and an organic solvent. The technique is based on the fact that many substances have different boiling point. During the distillation, liquid mixtures are separated by heating. The distillation process is the plant or animal source material being brought to certain predetermined boiling point. The steam is collected by cooling. In flavoring production, generally its industry is used to produce natural citral from lemongrass oil. Distillation have four parts. First is vacuum distillation. This is one often simple technique for contraction of essential oil before molecule distill. The raw material or crude oil heat under the vacuum pressly, control temperature, turning the component into vapor, which is the cool and condensed to a purified liquid products. Second, molecule distillation. This distillation technique employ the material to heat for breakfast. Possible time which at the same time allowing a very high vacuum to be achieved which lower the vaporizing temperature, contributing further to the limited exposure to heat. Third, alcohol co-distillation. It involves the addition of pure alcohol to the raw material, which are first treated with the water, followed by atmospheric pressure or low vacuum distillation of the alcohol and some water, which co-distill the more volatile component to yield a high aroma product. Fourth, steam distillation. Steam distillation is used as the general term to such a product which required roasting for flavor generation. The method includes wetting the material with moist gas, steaming at the varying pressure, adding hot water.
Artificial flavoring agents are created using chemical and synthetic methods to replicate specific tastes and aromas, with the exact process varying depending on the desired flavor. So here are some steps in the production of artificial flavoring substance. Firstly, identification of target flavor. Flavor chemists identify the desired flavor, whether it's a natural flavor found in fruit, spice, or other sources. Second step is analysis of natural sources. The analysis of natural sources of the target flavor identifies the key chemical compounds responsible for the taste and aroma. Third step is chemical synthesis or extraction. Chemists can create flavor compounds through chemical reaction or natural sources, allowing for greater control over the final product. The fourth step is purification. The compounds are purified to eliminate impurities and guarantee the high quality final product. The fifth is formulation. The formulation process involves combining purified flavor compounds in specific ratios to create a flavor profile that closely matches the target taste. The sixth is testing and adjustment. Sensory analysis evaluates the taste and aroma of an artificial flavor, allowing for adjustments to match the natural flavor or meet product requirements. The seventh step is regulatory approval. Artificial flavors undergo regulatory approval by agencies like the US FDA to ensure their safety and suitability for consumption in food products. And the last step is production and commercialization. Artificial flavoring agents, once approved, are produced on a larger scale and can be added to various food and beverage products to enhance their taste.
Flavor retention method is by encapsulation. Encapsulation is the technique by which one material or a mixture of material is coated with or entrapped within another material or system. The coated material is called active or core material and the coated material is called shell, wall material, carrier or encapsulant. Encapsulation of flavoring material is one of the most active areas currently under development. Encapsulation can protect flavors from ingredients and conditions like heat, moisture, and acidity that cause them to degrade. Next, we move on to the different of process of encapsulation of flavor compounds. First of all, the whole material and flavor are mixed into an emulsion and then go to the next process, which is divided into two processes, namely the chemical process and the mechanical process. Continues with the process of microparticles and ends with the process of controlled release. Next, this is a controlled flavor release. Controlled release may be defined as a method by which one or more active agents or ingredients are made available at desired site and time and at a specific rate. It divided into four. The first one is release of flavor by diffusion. Diffusion is controlled by the solubility of compound in the matrix. This establishes a concentration in the matrix which drives division and the permeability of the compound through the matrix. The principal steps in the release of a flavor compound from matrix system are diffusion of the active agent to the surface of the matrix, partition of the volatile component between the matrix and the surrounding food, and transport away from the matrix surface. Second is release of flavor by melting. This mechanism of release involves the melting of the capsule wall to release the active material. This is readily accomplished in the food industry as there are numerous materials that can be melted and that are approved for food use such as lipids, modified lipids or wax. In such applications, the particles are stored at temperatures well below the melting point of the coating, then heated above this temperature during preparation of cake. Type of controlled release is release of flavor by swelling. When matrix polymer is placed in a thermodynamically compatible medium, the polymer swells because of absorption of fluid from the medium. The aroma in the swollen part of matrix then diffuse out. And the last control release is release of flavor by degradation. The release of an active compound from a matrix type delivery system may be controlled by diffusion, erosion, or a combination of both.
Flavoring agents in food enhance taste and aroma, offering culinary diversity. Consumer preferences vary between natural and synthetic flavors, and health concerns arise due to allergies or sensitivities. Ingredient transparency is crucial, and concerns about processed foods high in flavorings arise. Cultural and regional preference also influence taste profiles, necessitating a balance between taste enhancement and health and transparency concerns.